Can you see my screen properly?
Yeah, I can.
All right, let me just. This is my AI ML RMSD app by me, and here is our problem statement. In my program, the problem which we are really trying to solve is to predict the root mean square deviation of protein structures in the field of biology. This helps us assess the quality of protein folding models. So in general, it's pretty rare to find RMSD or the root mean square deviation of protein structures, as explained in the next line. However, raw protein structure data often contains complex and high-dimensional features that need effective pre-processing and feature engineering to improve the predictions. This project aims to enhance the data set by creating a meaningful new feature encoding categorical information, all to improve the regression value predictions. And the reason that this would be important, like in the modern day lives, is because majority of protein, I mean, your body's made up all of protein. So everything in your body has different amounts of protein in it, right? Different protein models with different protein structures. And some of those can often like lead to diseases such as Alzheimer's. And so by predicting these, they can help solve many cases and help with the creation of drugs and medicines. Objectives and methodologies. In this project, our main objective was to accurately predict the root mean square deviation, RMSD. To achieve this, we focus on improving the quality of the input data through careful pre-processing and feature engineering. Here is a screenshot of our code for the feature engineering. Um, this involves scaling numerical features, creating new features, and encoding categorical information for better model performance. And here's like a result of it. It's like a small demo. Data exploration and feature engineering. In this portion of the project, we performed exploratory data analysis to better understand the structure and quality of the dataset. We examined the distributions, identifying outliers, assessed the relationships between features. Notably, the target variable, RMSD, was found to be skewed and many features required encoding. So here's just one of the many graphs. There were up to 9. It shows it being skewed to the left. Majority of them were skewed to the either the right or the left, depending on what variables were going into them. Model selection and training. In this stage, we trained several regression models to predict the RMSD values. Here's an example of the data and predictions that it was giving out. Based on the engineered features, we started with the baseline models models like linear regression, and then experimented with more advanced models later on. Some algorithms, such as decision tree, as I had used in the project. Each model was separated and was trained on separate datasets, while another portion was reserved for testing. Evaluation metrics such as RMSC, or root mean squared error, and R squared score were used to compare their accuracies. So here's an example of the code and some of the data sets displayed onto a graph. Model evaluation and results. In this phase, we explored the structure and the quality of the dataset by analyzing distributions, detecting outliers, and studying relationships between features. The target variables, RMSD, showed skewedness, as several input features prepared data for modeling using scaling and transformation techniques to improve regression performance. Data analysis and EDA. So in our exploratory data analysis, it revealed that the clean dataset contained about 44,019 protein structure records across 10 real valued features, all on different scales with no missing values. Now, because the number is so high, it can be often hard to see which data is right. And so before this, actually, it was 46,000. So we took out 2,000, almost 2,000 through data cleaning. Most features, including the target RMSD, display right skewed distributions indicating outliers. Overall, RMSD graphs are varying and have different relationships, with F3 and F4 are fractional values between 0 and 1, and F1, F2, and F5 have a more moderate relationship. These are the F3, F1, F4, and F5 are all different graphs of the data sets as seen here. This was a distribution of F1. Model interpretation and analysis. By evaluating the different regression models for RMSE prediction, tree-based methods are consistently doing better than linear approaches, reflecting the complex, non-linear relationships within the protein data structure. Random forest was the best performer out of the bunch with an MSE of 22.3 and an R squared of 0.39, offering strong accuracy. XGBoost followed closely with an MSE of 22.56 and an R squared of 0.38. And here is our project link. Can you see
Yeah.
our project?
No, you have shared the PPT, so I'm not able to see the demonstration part.
All right, okay. Hold on. Let me.
The presentation was really good. You presented it really well, and from what you have presented, I can understand that you have used multiple models to pipeline everything in a good way, so that you so you get good results. So that's really impressive. Yeah.
Thank you for that. Thank you. So
And
here is
I
a.
one question. Maybe we can go with that after you complete the demonstration. Go ahead.
All right, all right. So here's, as I was saying, F1 and F2. These are just different variables that you can change at will, right? Each of these have a different amount of data sets assigned to it, and each have a different amount of data assigned to it. And so overall, you can, by changing all these variables and clicking predict RMSD, it should predict an accurate RMSD for your values that you have inputted.
Just think, could you close the pop-up window for the Meet because it's blocking the screen for me?
Oh, yeah, I'm sorry.
Yeah,
Can
yeah.
you see
Can you go
better
ahead?
now?
Yeah.
And yeah, this is my demonstration.
Just could you demonstrate again because it
Uh,
blocked the Meet for me.
okay.
Yes.
Yeah, okay. Sure. So basically by changing these values, right? Like if I was change this to 4, right? It would change the data set entirely sometimes, and sometimes it barely changes it at all, right? And so each value, like F1, F5, and F6, as said before, were skewed to different portions, so they have different ratios and values assigned to them. And so by predicting it, it does math on these values and it predicts an accurate output.
Okay. Yeah, that seems great.
Right.
Okay.
Yeah. And hold on. Wait. Okay, I'm okay. So, all right. And thanks for reading my presentation. And if you have any questions, I would be happy to answer them.
Yeah, I have a few questions. I would
All
like
right.
to know that you mentioned that you are using linear regression and also random
Mm.
forest classifier, right? So for
Yeah.
what purpose were you using linear regression and for what purpose you were using the random forest classifier?
So for the random forest, it was easier to get. Basically, it was just easier in general compared to the linear regression. I mean, linear regression was overall a lot slower to get the data. So I was using the linear regression for majority of the data sets at the beginning
Mhm.
and just creating the models in general. But then I started experimenting with different models, and I found out that that model was the random forest model was a lot easier to use and provided better outputs in general.
Okay, and
Mm.
this is good. So,
All right.
what have you thought? Some advancements or enhancements? What's next for this application?
What's next for this application? It could also we can also integrate like different aspects of AI into this as well, because at least when we were in the developmental phase of this, we were thinking about a different project. It was more based off of like how you can use AI to recognize pictures. So based off of that, some protein structures have different shapes and different sizes. So I was hoping to get enough data sets on those or data values on those, and then use that feature to help identify some of those protein structures based on things such as like the scans and stuff, and the different pictures that you can take through a microscope.
Okay, yeah, this seems good. This is this idea is very innovative, because I have reviewed so many projects, and out of that, this was something that really stood out to me. So that's really good
Mm,
because we have addressed